Okay, so this video is on logarithmic and exponential equations. And before I even start, I want you to recognize more than anything that there are multiple ways to represent the same thing. For example, if I write this number up, the number 4, there's literally an infinite number of ways to write something that is equivalent to 4, right? I could write 2 plus 2. I could write 10 minus 6. I could write 40 divided by 10, right? I could write the square root of 16, right? There's an infinite number of ways to represent the number 4, all right? So when I show you the definition on the next screen, I just want you to recognize that it's just a different way of writing the same thing, okay? So take a look. Okay, so over here on the left, this is considered logarithmic form, right? And over here, this is considered to be exponential form. They are completely equivalent and they are completely interchangeable, all right? And there's going to be times when one of these versions is easier to work with than the other. So when you get stuck, okay, not if, when, because it's going to happen. When you get stuck on a problem sometime in this chapter, the first thing you're going to want to do every single time is see if you can change it from one form to the other. All right, and then down here, I do want you to sort of notice that there are some conditions for this thing to work. All right, the A value, sometimes called the argument right here, has to be positive. All right, the base, which is what B is representing, the base also has to be positive, and B cannot equal 1. All right, so with that being said, let's see if we can switch this equation, all right? And currently it's logarithmic, right? It is currently logarithmic. We're going to change it to the other form, okay? So you just have to remember what goes where, all right? This is the base. This is the answer, and this is the exponent. Okay, so if you think about this, this means that the base raised to the exponent should equal the answer. Okay, and that is true. 3 to the 4th does equal 81. These two equations are representing the exact same information, just written a different way. Okay, I have a couple more examples of this. I just want to make sure you're really comfortable with it. All right, so the base, the answer, the exponent. Okay, they're always going to be in that order. It's log, base, answer, exponent. Okay, so rewriting this, we're going to have the base raised to the exponent equals the answer. Okay, let's try another. Example 3. All right, again, write the logarithmic equation in exponential form. Okay, so we've got a base, we have an answer, and we have an exponent. That's an A. Okay, here we go. So the base raised to the exponent is equal to the answer. All right, now, don't let this confuse you. It literally means the same thing. There are some things called natural logs, all right? And it's represented with ln instead of just the word log. Notice it doesn't have a base indicated, right? Like on the other one, there's like a little number down here, all right? This one doesn't have that. It's understood to be base E. And E is, it's lowercase, it's a constant. You can look it up. It's approximately 2.718. Okay, so it's kind of like pi, like there's a number that goes with that letter. Okay, but the rules are exactly the same. Okay, you're still going to have a base, you're still going to have an answer, you're still going to have an exponent. So let's move this up and try to do the same thing here. All right, again, this is considered to be logarithmic and we want it to be exponential. So there's a base, all right, it's sort of hidden and invisible, but the base does equal E. There's an answer and there's an exponent. Okay, so rewriting this, we're going to have E raised to that exponent equals the answer. Okay, let's try another. All right, so there is a teeny tiny little base here that you cannot see. All right, then there's this answer, right? All of this is considered to be the answer, and this is the exponent. Okay, so when I try to rewrite this with the base that I can't see raised to the exponent should equal the answer, right? Keep in mind, all of that is the answer. So yeah, e to the third does equal e to the third, right? That makes perfect sense. Okay, scooting it up. I think this is my last natural log one. Okay, so again, there's a base that we can't see of an e. All of this is considered to be the answer, and this is the exponent. So e to the negative 2, right? The base raised to the exponent should equal this answer. Okay, and again, if you look really close, that exponent is, or excuse me, that equation is true. Okay, so now I'm going to kind of switch it around on you just a little bit. So notice, now I'm giving it to you in exponential form, right? This has exponents in it, and I want it in log form. So just remember, this is the base, that is the exponent, and this is the answer, right? So when I write it in log form, it goes log base, answer, exponent. Moving it up, let's try another. All right, again, we have a base, we have an exponent, and we have an answer. So in logarithmic form, the order is base, answer, equal to the exponent. Let's try another. Okay, so again, we have a base, we have an exponent, and we have an answer. So log base answer equals the exponent. All right, let's keep going. All right, so now you're going to be asked to solve some simple equations. All right, so I have 2 bullet points here that are going to help you. Okay, this first one says, if the log of base b of x equals log base b of a, then x equals a, which hopefully makes sense as long as these bases are the same, right? As long as they're both b or both 8 or both 1500. As long as they're the same, then this argument has to equal this argument, okay? And again, I said this at the beginning of this lecture. If you get stuck, okay, when you get stuck, try writing it in a different equivalent form. All right, so let's try this one. I want to know what x equals, okay? So take a look. I have log base 7 on this side, and I have log base 7 on that side. If the log and the base are equal, it's automatic that the arguments have to be equal. So x equals 5. Okay, scrolling this up, here's example 11. Okay, and notice I'll be honest, I'm kind of stuck. I don't like the way this looks. I don't know what to do, so I'm going to write it in the other form. Just a reminder, this is the base, this is the answer, that is the exponent. So that would be 6 to the x equals 6. Oh, well, this makes a whole lot more sense now, right? 6 to what power equals 6? Well, that would just be 1. All right, think about this too. Isn't 6 over here, isn't this equal to 6 to the first? And it's kind of that same thing we were just talking about. If the bases are equal, then the other stuff has to be equal too. Okay, so again, something to think about. All right, so here we are solving for x again, and notice, okay, you can kind of tell I'm lazy and I didn't want to retype a whole lot of stuff, but I've got log base 7 and log base 7. All right, so if that's true, then these arguments have to be equal. That means that x has to equal 9 to the negative 1. And that is simplifiable. You do not want to leave a negative exponent in your answer, so that's equal to 1 over 9. Okay, now this slide has so much information on it. You definitely want to pause the video and copy this down. I'm not going to read them to you. Excuse me. I'm just going to actually try to use them, okay? So you may have to, like I said, pause and come back to refer to this. All right, here we go. So this is saying to evaluate, okay? What that means, in other words, is this is supposed to equal a number, Okay, it should equal a number. So let's see if I can manipulate it using some of the rules that were on the previous slide. Okay, one of the rules says that I can take this exponent and put it out in front of the log. So this actually equals this. Okay, and then this is saying, right, if you look at it really close, I have a base and I have an answer, right? This is saying I have a base of 5 and an answer of 5. So the question is, what is the exponent that works in there, right? 5 to what power equals 5? And that answer, ladies and gentlemen, is just 1. This stuff in the parentheses equals 1. So then, when I multiply, I get 3 times 1, which is 3. Okay, and scooting it up, this is actually my last example. Thank you for your time and attention. Okay, so this is in exponential form. This is the base, and all of this is the exponent. Okay, so think about this. When you raise a number to an exponent, right? Like let's say that exponent was 2. Then you would say, oh, well, the answer is 36, right? Or if the exponent was 1, you would say the answer is 6, right? So I'm trying to figure out what this answer is. I'm trying to figure out A. So what I'm going to do is I'm going to rewrite this whole equation here, and I'm going to try to solve for A. I just have to write it in log form. So here we go. So it's log base answer, which is what I don't know. It's what I'm trying to figure out, equal to this exponent, like the whole flippin' thing. Okay, so I'm going to grab a highlighter, right? Because you've seen me do this before. If I have log base 6 on this side and log base 6 on this side, that means that these two arguments have to be equal to each other. So the answer that I'm looking for, right? We said we were going to solve for A, equals 2x plus 5.